The Earth is warming. The Arctic region is experiencing amplified warming much faster than the global average. This phenomenon, known as Arctic amplification, impacts the Polar Vortex, a large area of low pressure and cold air around the North Pole. As the Arctic warms, the temperature difference between the Arctic and the tropics decreases, weakening the polar vortex. A weaker polar vortex can become distorted, allowing frigid Arctic air to spill southward into lower latitudes. This can bring extreme The weakening polar vortex is like a door left ajar, allowing blasts of Arctic air to escape and plunge southward. A weakened polar vortex becomes less stable, allowing frigid air to flow towards lower latitudes. This manifests as extreme cold snaps and winter storms in regions that typically experience milder conditions. Recent years have seen record snowfall in the Gulf Coast and frigid temperatures in the Midwest. These events show the polar vortex's influence on weather patterns far beyond the Arctic Circle. Southward intrusions of Arctic air can disrupt the jet stream, leading to prolonged periods of extreme weather. Infrastructure can fail, leading to power outages and transportation disruptions. Agriculture suffers as crops are damaged by unexpected frosts, and human health is at risk, with increased cases of hypothermia and respiratory illnesses. The polar vortex, a swirling mass of cold air high above the Arctic, plays a crucial role in regulating Earth's climate. Picture it as a spinning top, its stability dependent on the temperature difference between the frigid Arctic and warmer lower latitudes. This temperature gradient fuels the vortex's rotation, keeping it strong and contained. However, as global warming accelerates, this balance is disrupted. The Arctic is warming at twice the global average, known as Arctic amplification. The Arctic, once a frozen expanse, is warming at an alarming rate. This phenomenon, known as Arctic amplification, is like turning up the heat on a stove. The pot closest to the flame heats up faster. As sea ice melts, it exposes darker ocean water, which absorbs more solar radiation, further amplifying warming. Warmer temperatures alter air currents, potentially disrupting the polar jet stream and leading to more frequent incursions of warm air into the Arctic. A warmer Arctic weakens the temperature gradient that maintains the vortex's strength and stability. This makes it more susceptible to disruptions and southward excursions. The potential consequences are more frequent and intense cold snaps, heavier snowfall events, and prolonged periods of extreme weather in mid-latitude regions. These events can disrupt infrastructure, agriculture, and human health, highlighting the interconnectedness of the Arctic and the rest of the planet. The relationship between Earth's warming, the weakening polar vortex, and the surge in extreme cold events is a complex puzzle. While evidence suggests a connection, scientists are working to understand the intricacies of this relationship. Further research is crucial to address key questions. How much of the recent extreme cold can be directly attributed to Arctic warming and polar vortex disruptions? Will these trends continue, and how might the frequency, intensity, and geographical reach of extreme cold events change in the future? What are the long-term implications for ecosystems, human societies, and global climate patterns? Answering these questions requires enhanced monitoring, advanced modeling, and international collaboration. By investing in research and fostering international cooperation, we can gain a deeper understanding of the complex links between a warming Arctic, a weakening polar vortex, and extreme cold events. This knowledge is essential for developing effective adaptation and mitigation strategies to address the challenges posed by a changing climate.